Hello and welcome back to our discussion about experiments in Chapter 4 for AP Statistics. We got a lot of stuff to cover, not really deep, but a lot of content in terms of definitions. So we want to talk about observational study versus experiment, the language of experiments, how to experiment badly, and how to experiment well. We'll talk about the randomized comparative experiment. We'll talk about 3 principles of experimental design. What can go wrong in experiments, inference for experiments, blocking, and matched pairs design. All right, so let's talk about observational study and experiments. So an observational study looks at individuals and measures a variable of interest, but does not attempt to influence the responses, meaning instead of going in and changing some variable, the observational study just observes what happens in a given situation. Experiment, however, deliberately imposes some treatment or changes a variable on an individual to measure their responses. All right, so let's see if we can take a look at an example. Actually, let's talk about lurking variables. All right, so a lurking variable is a variable that is not among the explanatory or response variables, and that we don't really consider or know about, but it may influence the response variable. So an example would be women who took hormones were shown to have a lower incidence of heart attack. But a lurking variable could be that the women who take hormones are more proactive about their health, and this proactivity has more influence as a lurking variable on the incidence of heart attacks than hormones. Right? So a lurking variable is something that it might be not very overt as a variable, but something that we need to consider as part of the evaluation of the response of a given individual or set of individuals when taking a look at a data set. All right, co-founding. Co-founding occurs when 2 variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. So we go back to that prior study. If we have a study of women taking hormones and heart attacks, women who took hormones had to visit their doctor more frequently. And so it could be that seeing their doctor influenced the incidence of having heart attacks. And so the process of taking hormones and seeing their doctor frequently are co-founding variables. And also the going to the doctor might also be a lurking variable if we're just studying the influence of hormones on heart attacks. So it could be that doctors influence the incidence of having heart attacks. So now we've co-founded or confused, let's say, the 2 variables because we don't know which one is really responsible for decreasing the likelihood of having heart attacks. Either taking the hormones or visiting the doctor, or both could be influencing that outcome. Okay, so this brings us to homework 4.2.1. So this is the work that you're going to do and submit. All right, so researchers study the impact of screen brightness on battery life. 15 randomly selected computers were put on the brightest setting. Another 15 were put on moderate brightness. Then the researchers measured how long each battery lasted. Is this an observational or experimental study, and why? So you can copy this down. And then I am going to move on. Okay, so let's talk about the language of experiments. All right, so treatment. Treatment is a specific condition applied to the individuals in an experiment. If an experiment has multiple explanatory variables, a treatment is a combination of specific values of the variable. All right, experimental units. Experimental units are the smallest collection of individuals to which treatments are applied. When the units are human beings, they're called subjects. All right, so experimental units are smallest collections of individuals to which the treatment is applied, and when they're humans, they're called subjects. Factor is another word for explanatory variable. And then a multi-factor experiment is one in which different values of a variable or multiple explanatory variables are applied. right? So we could give doses of 5 milligrams, 10 milligrams, and 15 milligrams of that hormone that we were discussing, which would make it a multi-factor experiment. All right, so we want to identify the experimental units, explanatory and response variables, and treatments in this experiment. So I'm going to go through this with you. A study compared two medicines to treat lice, ivermectin, an oral medication, and malathion, a lotion. Of 185 households treated with ivermectin, 171 were free from lice after 2 weeks. Of 191 that were treated for malathion, 151 were free from lice after 2 weeks. So identify the experimental units, the explanatory and response variables, and then the treatments for this experiment. So I want you to think about what this would be, and I'm going to give you the answer in a moment. So you can pause. Okay, so the experimental units were not individuals, they were households, because we talk about the households treated. The explanatory variable is the type of medicine, ivermectin or malathion. The response variable was whether the household was lice-free. And the treatments specifically were ivermectin and malathion. Okay. So this brings us to second round of homework, 4.2.2. All right, so a study of treatment of common medications compared to medications to help increase AP stats absorption. So again, a study of treatment for AP stats compared to medications to help increase AP stats absorption, an oral medication called autenmectin and a topical lotion called malathion. Researchers studied 712 people in 386 hamlets in 6 areas around the world. Of the 195 hamlets randomly assigned to autenmectin, 170 showed improvement in AP scores after 2 weeks, compared to 151 out of the 191 who used malathion. Identify the experimental units, explanatory and response variables, and the treatments of this experiment. So I'm going to pause here while you take this down. And then I'm going to move on. Okay, so let's talk about how to experiment well, the randomized comparative experiment. So we're getting to halfway there. So a random experiment or assignment is an experiment. A random assignment means the experimental units are assigned to treatments at random. That is using some sort of chance process. So let's say we want to conduct an experiment that compares online to in-person learning. We have 50 students and we randomly select 25 to be in the online experiment. And then at the end, there are 25 in each category, both online and in-person. Okay, completely randomized design is where the treatments are all assigned to the experimental units by chance. Back to our online learning example, each individual is randomly assigned to online or in-person learning. This means that there may be more or less than 25 people in each group. So we have 50 people, and then we run a spinner. Either they pick online or in person. And so the likelihood is that there's pretty close to 25, but not all the time there will be 25 people in each group. So the control group is a group that does not receive any treatment, but does not know that they are not receiving any treatment. So this is a baseline group by which we can complete and compare the treated groups. So this is important because sometimes we'll talk about a placebo effect where people who feel that they're getting some sort of treatment and know what they're being treated for may inadvertently improve in that given area just because they think that they should be improving. Okay, so as an example, this year Homestead offered an SAT prep course online. The average score of students who took the course was 1780. Previously, Homestead offered only in-person courses. The average score over the past 10 years is 1620. Can we conclude that online courses were more effective? And what can we do to make this comparative evaluation more meaningful? All right, so No, we can't, as it turns out, for this particular study, the students in the online course had a higher GPA. So the fact they took the online course superficially looked like the online course was better. However, in reality, it was really a result of the higher GPA for these students. So can we conclude? No. What could we do to make this comparative evaluation more meaningful? Well, we could normalize for GPA between the two sets of learning situations. We could also do some randomized assignment as well. And then we could hold this experiment for longer than 1 year, so we have more years for the study. Okay, this brings us to your third set of homework. Experiment was done to measure the effect of caffeine on pulse rate in students. 30 students volunteered for the survey. These students' pulse rates were measured, then they drank a Coke. 10 minutes later, their pulse rates were measured. It was noted that the average pulse rate went up by 17%. What can we conclude about this experiment or from this experiment, and what is wrong with the experiment? All right, so I'm going to move on in a minute, so please finish copying this down. All right, so let's talk about 3 principles of experimental design. All right, so 3 principles of experimental design. Control. So to avoid lurking variables, we're going to use a comparative design to ensure that only the systematic difference between the groups is administered. So you have 2 groups, everything's the same, except for one, you just change one variable, and that's it. 2, we're going to have a random assignment, so we're going to use impersonal chance to assign experimental units to treatments. And then 3, we want to use enough experimental units in each group so that any differences in the effect of the treatments, any weird results, can be distinguished between chance differences and then also between groups. So we need to use enough experimental units in the study in order to make some conclusive statement. By using enough experimental units, then we kind of standardize any of the abnormalities between people or the experimental units. Right, so this brings us to homework 4.2.4. How can we work the Coke experiment to test the effect of caffeine on pulse rate? So talk about control, random assignment, and replication. So how can you modify that experiment that you just worked on? So please take a moment here to finish this, or pause and write this. Okay, this brings us to number 6. What can go wrong with an experiment? All right, so placebo effect. So the placebo effect says that sometimes if subjects believe that they're being provided with a treatment, then the improvement is going to occur just because they think that they should be improving. So subjects who receive a pill which suggests a treatment will improve on the response variable, even though the pill itself is benign. So it's important to give a placebo to subjects so everyone thinks they're receiving a treatment. Otherwise, the improvement of responses might not necessarily be distinguishable from the actual treatment and the expectation of improvement. So for the hormone example, perhaps we give everybody a pill. Everybody goes to the doctor, but no one knows what that pill contains except the experimenters. All right, double-blind experiment says the experiment in which both the subjects and those conducting the treatment, so for example, the doctors who are prescribing the medicine and checking up on the women who take hormones, are not aware of who is being treated. Because sometimes if the people who are conducting or administer the treatment are aware of who they're treating, they may say or act in a way to convey expectations about how the results are supposed to be. So double-blind means both the experimental unit and the person who's doing the treatment, or the subject and the experimenter, are both blind to the experiment. All right, so this brings us to classwork 4.2.4. Music students have a hard time accurately evaluating their own performance. To help, half of a 30-person class were assigned to evaluate the performance by discussing it with a small group of other students. The other half just videotaped and watched their performance. Then students' evaluations from both groups were compared to overall evaluations. And it was found that students who discussed their performance in a small group were more accurate or more in line with other people's assessments. So 1, outline a completely randomized design for the experiment. 2, describe how you would carry out the random assignment. And 3, what is the purpose of the control group in this experiment? All right, that brings us almost to the end, but we have to pause here because we're over our time. Please come back and join us when we continue this discussion on experiments for chapter 4.2.